Welcome students. I hope you all are fit and fine at your homes. In this very first video for this chapter, that is magnetic effects of electric current, we will discuss about magnets, magnetisms, different types of magnets and their properties. So let me start with the very first topic, that is magnetism. What is magnetism? When we talk about magnetism, it's an invisible force which attracts any metallic object or magnetic object towards a magnet. Like as if we put any iron needle near a magnet, the magnet attracts that iron needle, and this process through which a magnet attracts an iron needle is magnetism. So when we talk about the types of magnet, we have basically four types of magnet, and there are some various type of example of these magnets, but basic magnets are bar magnets, horseshoe magnets, circular magnets, or very famous compass magnet. So, and there are some natural magnets also, which is magnetite or lodestones. Lodestone is a very famous or very natural magnet which is oriented by ores. And bar magnets, horseshoe magnets, circular magnets, and compass needles, these all are man-made or artificial magnets. All magnets have two poles, that is North Pole and South Pole. As you can see on the screen, we have three types of magnets at here. The first one is horseshoe magnet, or you can say U-shaped magnet. The second one is ring magnet, and the third one is bar magnet. In the very first magnet, that is U-shaped magnet, you can see two poles, that is North Pole and South Pole. In the ring magnet, you can identify the North Pole and South Pole at the upper part and lower part of the magnet. Like as at here, you can see the upper part of magnet, which is this one. This is indicating North Pole of the magnet. And the lower part of the magnet, which is this one is indicating the South Pole of that magnet. Same as in the bar magnet, you can see this one side means the left side of the magnet indicating North Pole, and the right side of the magnet indicating South Pole. This one is about the poles of a magnet. Now we will discuss about the very first property of a magnet, that is attraction. When we talk about the attraction, you all know about the phrase opposites always attract. The same phrase is applicable in this property. According this property of attraction, when two different poles put together for a magnetic field or in a magnetized area, they will attract each other. Like as if we put this south pole near to this north pole, and the magnetic field of these magnets is in this area, then this south pole will attract the north pole, and this north pole will attract the south pole, and this one is property known as the property of attraction. So poles that are different attract each other. This means that invisible magnetic force will pull the poles together like this. I hope this will clear to all of you. When we talk about the property of attraction, means we are talking that these magnets, or they will attract to each other. Same like as attraction, there is second force, that is repulsion. So when we talk about the repulsion, it means when we put same types of two magnetic poles near to each other, they will repel. Repel means they will put away or push each other apart from them. Like as you can see on the screen, that if we put south and south pole near to each other, and if I put south pole and south pole of a magnet at here, they will repel each other in the opposite direction, like this one direction and this one direction. This is the property of repulsion. In attraction and repulsion, in attraction, two opposite poles attract each other, and in repulsion, two same poles repel each other or push each other away from them. Okay, now we have to talk about the magnetic property, magnetic materials or non-magnetic materials. Some metals are magnetic and some metals are non-magnetic. What is the basic meaning of magnetic and non-magnetics? Magnetic means those metals which can attracted by magnets, and those metals which can't be attracted by magnets, they are non-magnetic. So let me take a few examples, like as if I take aluminium. Aluminium is attracted by magnets or not? Yes, aluminium can't be attracted by magnets, so it's a non-magnetic material. Same like if I take the nail of iron, is it magnetic or non-magnetic material? Yes, if we put the iron nail near to the magnet and it will attract the iron nail, then we can say an iron nail is an magnetic material. So here you can see few examples like as an rubber ball, a pencil, a nail or a pin. And you can identify which one is a magnetic material or which one is not a magnetic material. Like as ball doesn't attracted by magnets, so it's a non-magnetic material. But the iron nail will be attracted by magnets, so it's a magnetic material. Same as for pencil and the pin. So now the first question, are all magnets have the same shapes or they are different in shapes? No, there are lots of different types of shapes, and here we will discuss about the three one, that is horseshoe, bar magnets and circular magnets. Same like as we have a lot of different shapes of magnets, and we will discuss further about these magnets. How many or magnets have dash number of poles, or you can say how many number of poles and magnets can have? Yes, you can answer this question. Okay, every magnet have two poles, that is south and north pole. Next question, what different poles of a magnet do? That is the first property of magnetism. If we put north and south pole near to each other, what they will do? Very good. Different poles always attract each other. And what the same poles do? If we put south and south pole near to each other or north and north pole near to each other, what they will do? Very good. Same poles repel to each other. Are all objects are magnetic? Or we can say all objects can be attracted by a magnet? Is it true or false? False. Yes, only some magnets or some metals are magnetic. Aluminium is a metal, but it's not a magnetic. And iron, steel, nickel, they are also a magnet and they all are magnetics, metal. There are four things that we should know about magnets. The very first thing is magnets create an invisible area of magnetism all around it, that is called magnetic field. Means when we talk about the definition of magnetic field means the invisible area created by a magnet for the process of magnetism is magnetic field for that specific magnet. The north pole of a magnet points roughly towards Earth's north pole and vice versa. It means you all know that Earth is a big magnet and Earth have two poles, that is north pole and south pole. And when we talk about the circular or compass magnetic needle, the magnetic needle indicates north direction according to the north pole of Earth and south direction according to the south pole of Earth. And when we talk about the visibility or direction indication by compass needle, we always move according to the north pole of earth or north indication of the compass needle. The third point, if you cut a bar magnet in half, you get two brand new smaller magnets, each with its own north and south pole. For this, I'll take an example. Like as you can see, if I take this one is a bar magnet and we have this one is the north pole and this one is the south pole. Suddenly, due to some circumstances, I get this magnet and this magnet drop from my hand and this will be break down in two parts like as this one is broken. Now the north and south poles are aparted with each other. So what should I do? Should I connect these things for getting north and south pole, or can I get north and south pole in this condition also? Means now my magnet is like this, north and south. So in this condition, when the magnet is broken, the broken part, this will indicate south pole and this will indicate north pole by itself. That is the second property of magnet, that they will get their north and south pole when we break it in different parts. When we talk about the fourth property, if you run a magnet a few times over an unmagnified piece of magnetic material, such as an iron nail, you can convert it into a magnet as well. Like as if I tell you that if you put a nail or any magnetic material near the magnet, and like this one is our nail and this one is our magnet, and if I move this magnet around this nail for some time, I can see this nail also get magnetized and this one is also get behaving like a magnet. And this process, when this nail is also behaving like a magnet, this process is known as magnetization. So I hope you all are clear about this.